Functions. A function is a block of code that performs a specific task. Functions are used to organize code and make it more modular. Every Arduino program has at least one function, which is the setup function. This function is called once when the Arduino starts up. The loop function is called repeatedly as long as the Arduino is powered on. We can define our own functions to perform specific tasks. For example, we could define a function to turn on an LED or to read a value from a sensor. To call a function, we use the function name followed by parentheses. For example, to call the turnOnLED function, we would write turnOnLED. The Arduino C++ standard library provides many built-in functions that we can use in our programs. For example, the digital write function can be used to write a value to a digital pin, and the analog read function can be used to read a value from an analog pin. Function declaration, function definition, function calls. A function consists of two parts. Declaration, the function's name, return type, and parameters, if any. Definition, the body of the function, code to be executed. When the function declaration and definition are separated, it is clear where the function starts and ends. This makes it easier to find the function definition when you need to reference it. Additionally, separating the function declaration and definition can help to improve the performance of your code by allowing the compiler to optimize the code more effectively. Function's name. To create your own function, specify the name of the function, followed by parentheses. Return types. The void keyword indicates that the function should not return a value. If you want the function to return a value, you can use a data type, such as int or float, etc., instead of void, and use the return keyword inside the function. Parameters. The parameter is a variable defined in the function definition that receives the value. Parameters are specified after the function name, inside the parentheses. You can add as many parameters as you want, just separate them with a comma. Inside the function, you can add as many parameters as you want. You can also pass arrays to a function. While creating a function, you give a definition of what the function must do. For function definition, specify the return type, then write the name of the function, followed by parentheses and curly brackets for enclosing the body of the function containing the code of defined tasks to be executed. Function calls. Declared functions are not executed immediately. They are saved for later use. These executed when they are called to perform the defined task. To call a function, write the function's name followed by two parentheses and a semicolon. A function can be called multiple times. Argument. The argument is a value that is passed to a function when it is called, and the function must be called with correct numbers of arguments. Built-in functions. Digital input, output, I/O. Functions are essential for interacting with external components. The digital read function reads the state of a specified digital pin, returning either high or low. Conversely, the digital write function sets a digital pin to either high or low, controlling the voltage output. Before using a pin for digital I/O, the pin mode function must be used to configure the pin as either an input or output. Analog input-output I/O functions are used to interact with devices that use a continuous range of values, unlike digital I/O, which deals with discrete on-off states. The analog read function reads the voltage level on an analog input pin, returning a value between 0 and 1023 in Arduino Uno. The analog reference function sets the reference voltage for the analog to digital converter, which determines the maximum voltage that can be read. The analog write function generates a pulse width modulated PWM signal on an analog output pin, allowing for control of analog devices such as motors and LEDs with varying brightness. Within the Arduino 0, Do, and MKR families, additional functions control the resolution of analog operations. The analog read resolution function returns the current resolution of the analog to digital converter ADC, indicating the number of bits used to represent analog readings. The analog write resolution function allows setting the resolution of the pulse width modulation PWM output used by analog write, thus controlling the precision of analog output signals. These functions provide finer control over analog I/O compared to standard Arduino boards. Advanced I/O functions provide more specialized control over digital signals. The tone function generates a square wave of a specified frequency on a pin, useful for producing audible tones, while no tone stops tone generation. The pulse-in and pulse-in long functions measure the duration of a pulse on an input pin, with pulse-in long offering a timeout to prevent indefinite blocking. The shift-in and shift-out functions facilitate serial communication using shift registers, allowing for expansion of digital I/O capabilities by sequentially reading or writing data bits. Time-related functions are crucial for controlling the timing of events in a program. The delay function pauses program execution for a specified number of milliseconds, while delay microseconds provides finer-grained delays in microseconds. The millis function returns the number of milliseconds that have elapsed since the program started, useful for timing events and measuring durations. Similarly, micros returns the elapsed time in microseconds, offering even higher precision for time-sensitive applications. Math functions provide essential mathematical operations within programs. Abs returns the absolute value of a number. Constrain limits a value to a specific range. Map remaps a number from one range to another. Max and min return the larger and smaller of two numbers, respectively. Pow calculates a number raised to a given power. SQ returns the square of a number, and SQRT calculates the square root. These functions enable various calculations and data manipulations within sketches. Trigonometric functions are used for calculations involving angles and triangles. The cos function returns the cosine of an angle in radians. Similarly, sin returns the sine, and tan returns the tangent of the given angle. These functions are essential for applications involving geometry, physics, and signal processing. Character functions are used to classify and test individual characters. Is alpha checks if a character is alphabetic, AZ. Is alphanumeric checks if a character is either alphabetic or a digit 0 to 9. Is ASCII checks if a character is within the ASCII character set. Is control checks if a character is a control character, non-printable characters used for control functions. Is digit checks if a character is a numerical digit. Is graph checks if a character is a printable character, excluding spaces. Is hexadecimal digit checks if a character is a valid hexadecimal digit, 0 to 9, AF. Is lowercase and is uppercase check if a character is lowercase or uppercase, respectively. Is printable checks if a character is printable, including spaces. Is punct checks if a character is a punctuation character. Finally, is space and is whitespace both check if a character is a whitespace character, space, tab, new line, etc. Random number functions are used to generate pseudo-random numbers. Random returns a pseudo-random integer between 0 and rand_max, which is typically 32767 on Arduino. To ensure different sequences of random numbers are generated each time the program runs, random seed is used to initialize the random number generator with a seed value. Using an analog input for the seed, as in random seed, analog read, 0, is a common technique to introduce some level of randomness based on noise from the analog pin. Functions for manipulating bits and bytes provide low-level control over data. Bit creates a value with only a single bit set at a specified position. Bit clear clears sets to 0, a specific bit within a value. Bit read reads the value, 0 or 1, of a specific bit. Bit set sets to 1, a specific bit. Bit write writes a given value, 0 or 1, to a specific bit. High byte extracts the most significant byte, the leftmost 8 bits, from a 16-bit value. Low byte extracts the least significant byte, the rightmost 8 bits, from a 16-bit value. These functions are useful for bitwise operations, working with hardware registers, and optimizing memory usage. External interrupts allow the microcontroller to respond to external events asynchronously. Attach interrupt configures a specific pin to trigger an interrupt, which will then execute a designated interrupt service routine, ISR. You specify the interrupt number or pin number on some boards, the name of the ISR function, and the trigger mode, for example rising, falling, change, low. Detach interrupt disables a previously attached interrupt on a given pin. Interrupts are crucial for handling time-critical events and improving responsiveness. The interrupts and no interrupts functions provide global control over interrupt handling. Interrupts enables all interrupts that have been configured using attach interrupt. Conversely, no interrupts disables all interrupts, preventing any interrupt service routines, ISRs, from being executed. Disabling interrupts is useful for protecting critical sections of code where an interrupt could cause unexpected behavior or data corruption. It's important to keep interrupt disabling periods as short as possible to avoid missing important events. Communication functions enable data exchange between the Arduino board and external devices. Serial. This is the primary method for communication with a computer via USB. Functions like serial.begin initialize the serial port at a specified baud rate. Serial.write sends data, and serial.read receives data. SPI. The SPI library facilitates communication with devices using the Serial Peripheral Interface. It's a synchronous serial communication protocol. Functions like SPI.begin initialize the SPI bus. Stream. The stream class is a base class for various input-output streams, including serial and file. It provides common functions for reading and writing data, such as available, read, write, and functions for parsing data like parseInt and parsefloat. Wire. The wire library enables communication with I2C, inter-integrated circuit devices, also known as TWI, two-wire interface. It uses specific pins, SDA and SCL, for data and clock signals. Functions like wire.begin, wire.requestFrom, wire.begin transmission, and wire.write are used for I2C communication. USB functionality allows certain Arduino boards, specifically those based on the 32U4 and SEMD microcontrollers, to emulate USB devices like keyboards and mice. The keyboard library provides functions to send keystrokes to a connected computer, including keyboard.begin, keyboard.print, keyboard.press, and keyboard.release. Similarly, the mouse library offers functions to control the mouse cursor, such as mouse.begin, mouse.move, mouse.click, mouse.press, and mouse.release. These libraries enable creating projects that interact with the computer as a human interface device, HID.